Hello, and welcome to Energy Efficient Multifamily Building Operations, Energy Systems and O&M Opportunities, Part 1, brought to you by Oregon Housing and Community Services Multifamily Energy Program. In this segment, we're going to be focusing on building envelope and ventilation. Building envelope includes air sealing, insulation, and windows, and we'll start with air sealing. For air sealing in a multifamily building, we want to start by sealing the top of the building. This includes bulkhead doors, gaps around plumbing or flue chases, recessed lighting fixtures, roof wall junctions, or attic and utility accesses. Here we see a classic example of a bulkhead door that's not well air sealed. At the base of the door, we see clear evidence that warm air from inside is escaping to the outside, which is why the snow is melted next to the door. This photo shows an example of a gap around a plumbing or flue chase through which cold air can get in and warm air can get out. We also see the evidence from the dirt in the insulation because air is flowing through that insulation and the insulation is acting like an air filter. But insulation isn't designed to stop air leakage. It's only designed to slow the flow of heat. Here we have an example of a roof wall junction that should be air sealed, and the picture on the bottom right shows someone air sealing this junction with foam. Attic and utility accesses are another area that are really critical for air sealing. We go to lots of trouble to air seal and weather strip our main exterior doors, and then we have a door to our attic that oftentimes is nothing more than just a piece of wood held down by gravity. So we need to ensure that these doors are insulated and well air sealed as well. So those are the main areas that we need to seal at the top of the building. Now we don't have time to go through all areas of the building that need to be air sealed in a lot of detail, but we can hit on a few others briefly. We should also seal the bottom of the building. This can include pipe, cable, and other service penetrations, sealing the core wall to the floor slab, as well as sealing crawl spaces if we have them, and exterior doors. We also want to seal vertical shafts in our building, including stairways, fire hose cabinets, plumbing chases, and trash chutes. But for trash chutes, we're just sealing the doors and we're sealing the area around the trash chute between floors. Obviously, the trash chute itself is going to be totally open. Finally, we want to seal outside walls and openings, including weather stripping on all windows and doors, service penetrations on our walls, and electrical receptacles that may be on exterior walls. And those are just a few of the areas that we need to target for air sealing. In addition to air sealing, we need to ensure that our building is well insulated. Insulation materials may include fiberglass, cellulose, rock wool in either board or batt form, polystyrene board, which could take the form of EPS or XPS, polyurethane spray foam, or in some specialty applications, aerogel. Major insulation opportunities in existing buildings include attics, crawl spaces, garage ceilings, and exterior walls. In new construction, all of our walls, ceilings, and floors to unconditioned spaces need to be insulated. What about ventilation? If you've been into an existing multifamily building, you may have experienced that the building is underventilated, sometimes overventilated, maybe erratically ventilated, or even intermittently ventilated. The fact of the matter is, ventilation systems in multifamily buildings often don't work. So how can we get them to work? The answer is air sealing and controlled ventilation. There's a common saying in high-performance building, which is build tight and ventilate right. That's what we want to do. We want to start by reducing uncontrolled infiltration and exfiltration, or air leakage, using the strategies discussed earlier. Then we can use our ventilation system to bring in the right amount of air and remove the right amount of air. Not too much, not too little. And if we can achieve uniform and balanced flows from one apartment to another, that typically allows us to decrease our overall flows. So why might we have imbalances in flows from one unit to another? Well, there are a number of reasons. You might have taped up grills due to smell transmissions from other apartments, or even from bugs coming in. Grills might be covered by furniture. You could have duct leakage, or you could have dirty grills like you see in this photo on the right. Duct leakage is a huge source of ventilation inefficiency in existing multifamily buildings. And these are two great examples of areas where we are likely to see duct leakage. On the left, you see the termination point between the horizontal runout of an exhaust duct and the sheetrock. And if you look around the edges, that duct has not been securely connected to the sheetrock. And all of this area in red is area of potential leakage, where the fan connected to this will be exhausting the wall cavity instead of exhausting the room or the space that that fan is in. On the right, we see where the vertical riser meets the roof, and the areas highlighted in red are areas where the fan on the roof would end up, again, exhausting the shaft or exhausting the sort of interstitial space instead of actually the parts of the building that that shaft's connected to. Air leakage like this may represent up to 50% leakage in the duct system, so it's critical that we address duct leakage to ensure that our ventilation system functions properly and maintains balance.